how to start a plugin from scratch. Because when the world is a possibility, sometimes we have a hard time to start.
Yes.
So here is Alain.
Thank you. So I started work on a new plugin Boilerplate, and I want to first try to answer the question of why. Because apparently there is already such a thing as a boilerplate for plugins in multiple iterations. So why just add another one? First of all, the WordPress landscape is currently changing more rapidly than we used to. So there's we have been stuck with PHP 5.2 as a minimum for a very long time, which has just recently changed. So WordPress core bumped its minimum to PHP 5.6 with the plan to bump it to 7. So as you already heard from Jenny, there's a lot you can do already at the language level once you move your code to PHP 7 and beyond. That already improves everything. WordPress also uses this requires PHP header, and it also incentivizes updates, which means that in general we build in a lot of small functionality that tries to give you a reason to keep your PHP version up to date. So we expect this evolution to accelerate over time, and more people always running by default on the latest and greatest PHP versions. At least that's the goal. Currently existing plugin boilerplate code usually makes use of the lowest common denominator, so it just assumes that you want to code at the PHP 5.2 level, and worse, it even assumes that you want to code in the exact same way that WordPress core code has been built. But WordPress core is not supposed to be used as an example because it's a 15-year-old code base, or 16-year-old maybe already, and it's just very old legacy code that we cannot rewrite it because we want to have everything stay backwards compatible, but no one would write that code today in that same way. It's just, it was written in PHP, I don't know, PHP 3 or PHP 4 versions when the language was completely different. So you always need to keep that in mind. Also, I want to serve an educational purpose with this plugin boilerplate because I think that there's not enough code that actually shows you how to build something that you can easily maintain over a longer stretch of time and with growing complexity. Because it's very easy to start with a one-liner plugin, and if that's all your plugin ever needs to do, that's perfectly fine. There's nothing wrong with that. But if your plan is to build something more complex, then if you start in a very simplistic way, you will quickly notice that complexity not only grows linearly, but it grows as a hyperbole. So the more code you add, the worse it becomes to maintain everything, and you will add bugs at a quicker and quicker pace, etc., because your structure will not be adapted to more complex code. In the WordPress space, there's very few proper examples of how to build code in such a way that it can properly deal with arbitrary complexity, because most of the code starts simple in a simple way, and once it has grown past a certain point of complexity, well, it's too late to rewrite it from scratch, so it stays that way and people just have to deal with the consequences. It's also, I want to provide an environment where you can start from scratch with your new code, but that contains all the necessary framing around it, so you can start off with the right foot right from the beginning, because there are a few missing pieces to WordPress that make it so that if you would want to write your code properly, you need to come up with a lot of mechanisms yourself first, because WordPress doesn't provide them. And this plugin boilerplate, it is meant to provide some infrastructural helpers that allow you to build your code properly from the scratch and provide all the missing pieces that would be needed to do that. And this will lead to a sort of learning by doing. You will start in an environment where it's very easy to add proper code, and you can at any point examine what the framework, what the boilerplate code does. So that is easy to understand why these changes are and how you can better improve your code. So learning just by being inside of the code where you have something executable from the start is a very useful educational tool. There are a few considerations though that come with this. First of all, over-engineering is not only a bad buzzword, it is an actual problem. So if all your plugin is meant to do is add a filter somewhere, there's no point in using a plugin boilerplate like the one I will be showing you. Of course you can do that, but there's no benefit to be had. You will just have the overhead of the code and nothing more. So if you know that it will be a one-liner and always stay a one-liner, just put that one line into a PHP file and you're good. There's no point in going any further with this. So keep in mind that yes, you should always use best practices whenever it makes sense, but whether it makes sense or not is something that also depends on the actual problem you're trying to solve. Also, right now the code by itself targets PHP 7.2. The tooling I want to add will probably allow you to move that around in both directions, but out of the box the code supports 7.2, and that might be too aggressive depending on what market you want to address. So if you want to write a public plugin and you have a certain audience you want to target, you should first analyze what the PHP version distribution for that market segment is. Because although we hope that everyone uses the latest PHP versions all the time, that's just not the case, and 7.2 might be too aggressive depending on which market segment you want to address. So going to 7.0 or maybe even down to 5.6 might be something you need to consider. The code will allow you to easily adapt it to that, and I want to even provide automatic tooling for that. But know that this always comes with a drawback. So the lower you go in the PHP versions, the less tooling PHP will provide to you to lower the maintenance cost in the long term. So something like strong typing, which is only available with PHP 7, it will, after the initial investment cost of adding the typing everywhere, it will actually lower your general maintenance cost because you exclude entire families of bugs because they are just not possible anymore. And if you go down below versions like these and you add this vagueness again that comes with the older versions, well, it will add to your support cost in the long run. So if the question is whether you want to address more people or have cleaner code, keep in mind that the cleaner code will reduce your support costs and might be financially the better solution than adding one more segment of the market while then opening yourself up again to these elevated support costs that come with more possible bugs later down the road. Also, a last consideration, this entire boilerplate is meant to be used with object-oriented code, and while you can interject any code in between all the time, the full benefits only come with pure OOP code all the way through, because some of the tenets of object-oriented programming only make sense if you can enforce them, and enforcing only works at 100%. You cannot enforce something for 99% because then it's not enforced. It's just highly probable and nothing more. So keep that in mind if you add your code, that if you fall back to procedural code, it might have consequences on what types of benefits you get out of an infrastructure like that. So let's start first off with some of the PHP features. I will go quickly through this because Jenny already covered a lot of this, but I want to mention some more conceptual ideas nevertheless. So first of all, you should absolutely use auto-loading and namespaces. There's really no reason whatsoever now that PHP 5.2 is gone to not use them. And the namespaces basically mean that instead of fighting in the global namespace with your prefixes and hoping that you will not have any conflicts, it's very easy to just put everything into your own namespace. And then from that point on, you can use clean naming and clean short variable names, function names, whatever, that makes sense, not that reduce conflicts, because the conflicts are gone with the namespace. I recommend using PSR4. This is PSR, the PHP standards recommendations. And the PSR4 is the one for namespaces. And I will explain how that works in a minute. And you should usually stick with a vendor and then a package prefix as namespace root. So this convention of first using a vendor and then a package instead of only the package is generally used across languages, because if you only use package names, you'll have the same issue that we are facing right now with the theme or plugin repository, for example, that people come up with the same package names all the time, because it might be fun to call your package my plugin and there's someone else who already used my plugin before. So if you always use vendor first as your brand name, which might even be a trademark that no one else is allowed to use, and only then use the package, then you're usually safe. And the boilerplate allows you to use Composer as the system to manage your autoloading. So Composer can generate autoloaders in several different variations. For example, a flexible PSR4 based one for your development needs, and then an optimized class based one for the production side that is not as flexible anymore but runs faster, because on the production side you don't need the flexibility because you're not changing the production side. So Composer is the de facto standard to manage the autoloaders. However, this plugin boilerplate also comes with a bundled one in case you don't want to have the requirement on the Composer install step. So you can build your plugin so that if you just put it up on the plugin repository, it will be able to be just downloaded and installed and used, and there's no build step involved. Keep in mind, this only works if you don't use dependencies through Composer. As soon as you're doing that, the Composer install step is mandatory. You cannot get around it. Now a short explanation of how PSR4 works, the standard of how to autoload classes. It's a bit different than what the WordPress core uses and what they recommend for your file naming, but I think it's much preferable, and it is the standard in the PHP world. So I think in this instance, the PHP standard should trump the WordPress standard, because it has so many obvious benefits. So on the left side, you see your file system. On the right side, you see your class names together with the namespaces. PSR4 means that, first of all, you map a root namespace to a root folder. In this case, we opt to use the source folder as the root folder. This is again a de facto standard in the PHP space. And then here we have my namespace as the root namespace. So my would be the vendor. It's a bad vendor in this case, but just imagine this would be your my company. And namespace is the package in this case. So we have this, this root namespace is directly mapped to the source folder. And then we, PSR4 states that any subfolder in this root folder will map to a relative namespace inside of that root namespace. So if we have a subfolder shortcode, it will map to my namespace shortcode instead of just my namespace. And then finally, the file names exactly match one-to-one with the class names. So there's no guessing of how you can get from a class name to a file name. It's just the same thing, you just remove the extension. This is a very elegant way of dealing with this mapping, and in your file system you will immediately see cleanly how your object hierarchy is looking, how your class hierarchy looks. So you can then use these relative namespaces, like here MetaBox, shortcode, and view. You can use these to model your architecture so that someone looking at your code for the first time, they can immediately see what's going on by just the folders in this root source folder. So we're also using OOP with this plugin Boilerplate, and I'll try to explain what the main benefit of OOP is, of why you want to consider using it. So consider what traditionally PHP has been. You have a file with a PHP extension and you can execute it. That's usually a script, and when PHP started out, this was executed procedurally, meaning one line at a time in a specific order. That's procedural code. So this one file, if you just executed it, it did something, and then when it was finished, it exited the process again, and you're done. And as long as your code is at that level of complexity, this approach is perfectly fine. There's no problem with that. So if you need to write a quick migration script that includes, 20 lines of code, there's no problem just putting it into a PHP file and calling it directly with PHP and executing it. That's perfectly fine. The issue comes when your complexity grows. All of a sudden, while your PHP file, it starts having 20,000 lines of code. You think about splitting it up because the scrolling kills your mouse buttons, and you want to change something there. So then you have relationships between files and relationships between the execution flow amongst these files. So with two files, these relationships, it's still pretty easy to manage them, to have an overview of what's happening and keep everything under control. But the more files you add, the more of these random arbitrary relationships you have, and all of a sudden you have no clue what's happening anymore. So execution runs through multiple files. If you stop at any moment in any given piece of code, it's very difficult to know where did the execution flow come from, what was executed before, what will be executed next. It's very difficult to manage this in terms of complexity. And now on this diagram, it's not that I have 10,000 files here. It's still a pretty simple example here, but you can already see that these relationships, they grow quickly out of control. So what OOP does is it considers conceptual objects first instead of files. And these conceptual objects, they also have relationships amongst them. So you can see these arrows here. They are relationships that are not at the file level, but at the conceptual object level. And with these relationships, the thing is that if we build them in a proper way, all of a sudden we can ignore what's inside of the objects. So the objects become black boxes, and whatever complexity we have in a given object, we don't need to consider it when working on another object. So all of a sudden, all we care about are these relationships. And that's what object-oriented programming is about. It's not even about how you build your objects and class syntax and methods, etc. That's just irrelevant details. Object-oriented programming is about the messaging that goes on beyond, between objects. And that's what you want to model. So if you're thinking about object-oriented programming, it's not about writing code that is wrapped in class syntax. That's not the point. Of course, that's how you achieve it finally in PHP, but you're missing the point if that is all you're considering. If you want to model something in object-oriented code, you need to think about the conceptual objects. How do you split it in your problem space into different actors, and then you model the interactions between these actors. That's object-oriented code. And if you put in interfaces then for these interactions, all of a sudden your complexity is even more reduced, because all you need to care about is the interfaces and the interactions between these interfaces. And the rest can be swept out and replaced whenever you think it needs to be done. And whenever you need to make changes, these interfaces, they act as boundaries. So you can just concentrate on this one piece of code, and whatever changes you do, they can't break the rest of your code, which is the case with procedural code. With procedural code, if you make a change here, it breaks in 10 other places. And with object-oriented code, if you have these interfaces in place, all of a sudden you have this safeguard where you can split up the complexity and just deal with the small part of the complexity instead of the whole. So we'll never need to consider the entire project when making a change. Which means that the project can grow arbitrarily in complexity and you can still manage it. So another feature we want to use is type hinting. I already mentioned it briefly. Type hinting means that you let PHP know what type of data can go into methods and what type of data will go out of methods. And this seems like something really rudimentary to do and not very useful. But think about it like this. If you say in a given function, well, this function can return an integer value, then you'll have all the other functions that want to use this function. They have to rely on this knowledge, and based on this knowledge, they do their processing. For example, if they know that you will return an integer value, they know that they can do calculations immediately without transforming your data, because it cannot be a string or an object or whatever. If you state that, well, I can return an integer or a string or an object, then the other function consuming your code knows that, well, I need to do some safeguards first. With WordPress, for example, you probably, if you do development on themes or plugins, you probably have seen this already, that you look at the documentation of a given function or method, and it says, yeah, it returns this and this, and then you use it, and all of a sudden you get a random error, and it's because it returned something that was not documented, that was even unexpected. And that can happen easily with WordPress because it has this action and filter plugin API. So for most of the functions you're using, someone else can actually filter the output first and return whatever they want. So this is the most common source of bugs in WordPress development, because the typing is completely unreliable, and you can never be sure of what goes in and what goes out, and so it ends up being that for a given piece of logic, you have 3 lines for your logic and 50 lines to just prepare your data to make sure that it is what you expect. Type hinting, first of all, means that you enforce certain types as input or as output, and PHP will check the type and throw an exception when the type is not correct. So you will at first turn these random bugs into immediate fatal errors, which doesn't sound that nice at first necessarily. But what this does is, first of all, as a developer, you get an immediate notice that something is off, something is not as expected. So that should already raise a warning flag for you. And secondly, if you put this in your code, at one point you will have a sort of protective layer where any data that comes in is type hinted. And inside of this protective layer, all of a sudden, you have enforced a given data integrity, because all of a sudden you cannot get the wrong data anymore. So all your methods inside of this protective layer, they are very clean. You have one-liner methods that know that when they say I get a string, it is a string and cannot be anything else. So they just do their operation, return their result, and that's it. So instead of all these if, else, then, switch case stuff to just check your data, you just deal with the logic, because you already enforced strong typing beforehand. The This means, though, that you need to be careful when starting with this, because before you're enforcing it, it just means that you're turning a lot of latent bugs into immediate fatal bugs. So be very careful when just turning strict typing on for information you're directly getting from WordPress, because WordPress is to be considered completely unreliable. You cannot ever rely on what WordPress returns as data. And also, this type hinting does not only work with scalar values, but it also works with objects, and that's where the magic all of a sudden starts. So you can type hint for value objects, which means that if you say, okay, send email, I have a send email method, and it accepts an email. In regular WordPress code, it would just accept an email and then get a string or null or an array or a WP error object or whatever. So that's the worst starting point. If you now turn strict type hinting on, you could at least say, okay, send email accepts an email of type string. So you cannot get random objects or null or anything. The error will need to be handled before that. So your send email method can be clean and can assume that it's a string. But now inside of your send email, all of a sudden you need to add additional validation code, because if something is a string, it is not necessarily an email. There's only certain configurations of letters that make up an email, that make up a valid email. And if you have a string like, if you have an empty string, for example, because the user did not come with an email, then this will still fail. So that's why value objects come in handy when you combine them with type hinting. You can have a value object email, for example. If you create a new object of type email, you pass it a string and it validates that this string is actually a valid email. And from that point on, whenever you say, oh, this is an email, you have a guarantee that it cannot be anything else than an email. So in your send email method, you could type hint against the email value object instead of a string, and then all of a sudden your send email method can just assume that, well, I can only receive a proper email. There's no way around it. So that code again becomes cleaner. Of course, that means you'll need to deal with the value object in an earlier location, but that's only a problem in the early stages of using such approaches. If you use this across your entire code space, well, then at one point you turn a random string into an email, and everywhere else you can just use it. So the benefits come with just being consistent with this. Exceptions. So I already noticed a WP error object. It's one of my favorites in WordPress. Basically, any function, any method you call in WordPress space, it can return a WP error object. You're never safe from them. They invade everything. Because the functions that don't create WP error object themselves, they can still receive it from a filter from someplace else. Because the WP error object is an error handling mechanism that it uses the return value. So it uses the standard mechanism of passing data through your function calls, through your call stack, to pass this error information on. So it actually replaces your data, and this means that if you have 10 calls in a row of functions and the first one has an error condition, it creates a WP error object, and the last one knows how to deal with that error condition. Well, the WP error object needs to be passed through all the functions to that last one. It means that all the functions in between need to be aware of the WP error object and check for it, because otherwise they might do operations on it that will just break your code. So that's an issue with using the direct data return mechanism for error information. So exceptions are the object-oriented approach of dealing with this, and they actually consider them a transport mechanism. So in our same example with these 10 function calls, if function 1 has an error condition, it throws an exception object. And it throws means that it will break every function until it encounters one that actually catches the exception it created. So that catches either that specific exception or a family of exceptions that matches that one. So all the functions in between, if they don't catch this exception, so if they don't state that they can handle this specific error condition, they will just be bypassed. Because they cannot do something properly, they are not able to deal with the error condition, the valid data is not there anyway, so there's no point in executing this. So the exception will just bypass everything until it hits the catch statement that actually catches this specific exception. So all of a sudden, the code in between, it can completely ignore any error condition that it doesn't know how to deal with. So you don't have all these, if is WP error, then our alternative code, you can completely skip this. You just throw an exception in one place and catch it at the earliest point where you can properly deal with it. If you cannot ever deal with it, then just pass it on and maybe the surrounding framework can deal with it, otherwise the developer or their boss will know about it. This transport mechanism is very valuable. And the exceptions can also, as they are objects, they can encapsulate any logic that comes with creating the error messaging, collecting data to pass along, etc. That can all be properly put into this exception object. So the code that throws the error condition does not even know how to actually now deal with the messaging or something like that. So that was a short language overview. Now the architectural overview. First of all, the file layout of this boilerplate. There's a single bootstrap file. So the bootstrap file is the first one that WordPress hits, where you have the comment to state that this is a plugin. This is called the bootstrap file. And the bootstrap file should be the only file in your complete code base, in your entire code base, that has side effects. So a side effect is something, is called when, if you include this file, something happens. And it sounds a bit counterproductive that you would have all the other files not have something happen when you include the files. But it basically means that all the other files will just be declarations. They will not execute any PHP statements. You will just declare classes, traits, interfaces, and so on. And the bootstrap file is the only one that actually does something. All the rest is just a consequence of the bootstrapping file pulling everything in. It's the only file with side effects. And for example, in terms of security, all the other files, if someone manages to hit your server and directly execute that file, well, they declare the class in a process that exited immediately. So there's no security implications at all, because nothing happens. It cannot have side effects. The classes are regrouped in the source folder. This is a recommendation that comes from the PDS/skeleton package. This is a package where a well-known PHP developer has taken the time to go through all the PHP frameworks, all the existing PHP code, and look at the most popular trends and build a sort of standard, but not by just defining something, but by looking at how people actually use PHP and what makes most sense. So it's just a common sense approach of creating a new convention to use. And in this convention, for example, all your class declarations go into a source folder, and that's the one that is mapped to your namespace root. Just a quick note, you see often people use an includes folder, for example, and generally the convention is that includes is for procedural code, so files with side effects. And source is used for object-oriented code, so files without side effects. So normally, if I go into a new package and I see an includes folder, I assume this is procedural code, and when I include code like that, it will execute something. It will immediately do something. So that's an important distinction to make. So here you see what that at its most basic would then look like. The plugin folder contains the bootstrap file, and then only the source folder where you have this hierarchy of subfolders and classes as it was shown in the PSR4 example. And the bootstrap file is the one that will then pull in the autoloader and trigger the first object that is responsible for everything. Here you can see an example of how such a bootstrap file would look. Again, this is very basic. Also a quick note, the code examples you see here, they are not necessarily what is in the plugin boilerplate. Most of this is heavily simplified to fit it into slides, because the boilerplate is not only a bit more detailed and elaborate, it also contains lots of comments. So this is not the exact code from the boilerplate. So here you can see, first of all, we start by opening our PHP tag, adding the plugin header so that WordPress knows it's a plugin. Then we add a namespace. This is the first thing we do. We add a namespace, and from there on, we're safe from conflicts. This only works if you, in your PHP 5.2 compatibility, with which you should by now, because 5.6 is the minimum, the recently bumped minimum for PHP core. Because otherwise you get a pause error if you use namespace in PHP 5.2 bootstrap file. Then, first of all, because this is a file that has side effects, we make sure that we can only run this if WordPress is being loaded. So there's multiple ways of doing that. Just pick whatever you prefer most. Here I'm checking for apps path, but there's multiple other ways of doing that. Then we're loading our autoloader, because before we do that, and our entire class hierarchy does not exist, you can see a check here for is readable. This is not because I don't trust my hard drive. This is because if you use Composer in a plugin, you need to be aware of the fact that if someone pulls in your plugin and uses Composer at the side stack, then the vendor folder will not exist in your plugin. It will only exist at the site root, because there's only ever one vendor folder for Composer when it runs. And if you run it at the site stack level, it will be at the site root. So there will be no vendor folder in your plugin. But the site will be responsible for pulling in the autoloader from that vendor folder. So your autoloader will already be active at the point when you launch your plugin bootstrap file. And then here I opted to create a plugin factory which creates our plugin. It's one way of creating a shared instance. Yeah, there's multiple different ways of doing that, but yeah, it's basically the same thing. File exists means that it could exist but still not be readable, and you get an error that you don't have the permissions to load it. But, yeah. So plugin factory is a way of having a shared instance of a plugin without using a singleton, because the singleton, again, is something that breaks your OOP benefits that you want to work hard for getting. So the plugin factory that we have here, it will always return the same plugin instance. It's just that the plugin object itself, it's not a singleton, so we can properly test it and mock it and do whatever with it. And then with that object instance of the plugin, we call its register method. I'll get back to what that means shortly. So this is the kickoff of our plugin. And after that point, we're done with any side effects. We're done with the bootstrap file. The rest is OOP code, where the objects take over. They're not based on a given order of doing things. They're based on what the code will define how the objects interact with. So the life cycle of a typical plugin is bootstrap, then potentially activation hooks if you're activating a plugin. Then load the plugin, initialize the plugin, run the regular execution of the plugin, clean up after the plugin, deactivate if that is needed, and then shut down. And I'm stating these lifecycle events because it's important. The boilerplate code wants to build a modular approach to code. If you build something that's supposed to be modular, then any module needs to be able to hook into these life cycle events in some way, because otherwise you will need to hard code the behavior of the modules at a higher level if they do specific things in the life cycle. So what we do is instead have our plugin be very generalized, and each module decides when it needs to do what. So the modules themselves, they need to be able to hook into these lifecycle events. That's where services come in. So this is again a convention. I use the term module now. Usually when you split your code up into several different pieces of logic, we're talking about services. So you can use any big project of whatever scale and split everything up into services that interact with each other. It's a generic term to mean a unit of code that is self-contained. And the services can use other services. So you can build a hierarchy of services. They can interact with each other, depend on each other. It's just a unit of defining your concepts in your project. And what we want to do is give these services direct control over the lifecycle events of a plugin. And at that point, growing complexity means adding services. So where before growing complexity meant we had a hyperbolic growth in complexity, now we have at worst a linear growth of complexity. And at best it's even less, because with time more and more use cases can be solved with existing services. So these services, they need to be modular, they should be unified, so you don't want to hard code the usage of a specific service that defeats the purpose. They should be flexible, so that you can, for example, add a third-party plugin that modifies some services or adds services to your plugin to interact with them. They should be future-proof, so it's important that we don't code ourselves into a dead end, that we can always adapt in whatever ways our future requirements will want to challenge us. And they should be semantic, so I include marker interfaces. Marker interfaces, it's what you call an interface that does not actually define any real methods, but that's just there to mark something else. Okay, this is this type of stuff, this is this type of stuff. Because when you use these marker interfaces in later parts of the code, you can have generic handlers. So instead of saying, okay, this and this and this service needs to be registered, so needs to be hooked up to WordPress, we can say, okay, any service that is registerable will need to be registered. And all of a sudden, it's just a matter of adding the proper interface to the service instead of having a hard-coded list of services that need to do this and that. So the services themselves are self-contained and know when what should happen. And this means that there's no central place in your code where you need to hard-code any logic in some way. Here we have a quick example of how such a service-based architecture can work at its simplest form. The plugin is basically just two pieces. One piece to fetch the list of services that compose the plugin, and one piece to actually hook these services up with lifecycle events. That's the list of lifecycle events that I told you before. Usually the register call is the one that is responsible for adding the hooks. So whenever a service needs to be hooked into the WordPress lifecycle, we have a register call, and we add the registerable interface to the service. And so any service that is registerable will automatically be registered so that it has its opportunity to hook up with WordPress. Then this get services call here, for example, I showed that you can easily filter that. So any other plugin can switch out a service for another one, or add a service, or whatever. This is one way of doing it. It's not necessarily the only one, but it's one way of doing it. Now the concept of dependency injection. If we provide interfaces for everything and we type in against these interfaces, we can build properly decoupled code. So we can say, okay, this piece of code, it needs a database connection. It doesn't care what database connection it is. It needs a database connection. And with whatever database connection we got, we do this and this. So that's, for example, in this piece of code, you can see this is normally how you would do it if you don't use dependency injection. We have some service that does something, and it instantiates a new MySQL database to be able to get the lyrics in this case. This means that the some service, here in this case, it's directly coupled to the database implementation. And whenever we change the database implementation, we will probably break some service. I should use other names in my examples. With dependency injection, it basically means that you inject the database to use into your service. And then the service just stores this reference, and when it needs to use it, it just uses whatever it got. It doesn't care about where it came from. And you can go a step further. Instead of using a direct reference to MySQL database, you can use an interface instead. So some service depends on a database, but it doesn't directly depend on the MySQL database. And whenever we need to make a change later on, we just make sure that this new piece of code also adheres to the new interface. And all of a sudden, our some service does not need to be changed anymore, because we have a contract in place. So some service has a contract with a database interface, and we never touch that contract. It stays intact. This means that we are deferring decisions. So technical decisions are whenever we decide, okay, now we use MySQL database instead of Redis database. That is a technical decision. And these decisions can be deferred. So we don't want to make them in the first piece of code that needs the database. We also always want to defer them up higher into the hierarchy as far as possible. Because in every single piece of code where we deferred the decision and didn't make the decision, we're not relying on that decision. And so the decision can still be easily changed in that piece of code. It's only where we directly make such a decision that we also rely on it, and we need to adapt when we change a decision. And this is where the composition word comes into place. So with dependency injection, you move everything up in the hierarchy. So you inject your dependencies in a hierarchical tree fashion, and the composition root is at the top of that tree. And what that does then is, instead of having new calls all throughout your code, where you have technical decisions hidden in every single piece of code, and when you change the technical decision, you need to change that code as well, all of a sudden we move all of that up into some place in our code that is responsible for that. And every other piece of the code, it just relies on our contracts, and as long as we keep our contracts intact, they don't need to change with whatever, even if the project drastically changes in the future, if there are requirements changes that completely change some subsystems, it doesn't matter. Only these subsystems will need to be changed. The rest still stays intact. Another concept that we're using is views. So I'm going a bit quicker than because of the time. This separates presentation from logic. That is important for maintainability. It also provides out-of-the-box themability. So for any view we provide in the plugin, we can just copy that view into the theme and override it, and we're good to go. And in my view system, I also default to escaping. So whenever you use data, it will be escaped by default, just to keep everything safe. And if you want to use the raw data, you need to add the extra effort instead of the other way around and being unsafe by default. The usage, right now this is theoretical because the tooling is not yet ready. I'm still working on this, it's still an active project. But the goal is to have either Composer or WP-CLI be useful as generation tools, and there will also be a web-based generation form that you can just fill out, and that will send you a zip file of the plugin to start. And some of the customizations that will come along is to use Composer for dependencies, use PSRs for some other interfaces, like for example if you need logging, then you use the PSR3 logging interface and so on, and add optional subsystems that you can pull in that provide ready-made solutions for an assets pipeline, for example. Adding a service will then basically be just creating a class that implements the service interface and adding it to the get services class, get service classes array. So any piece of new code that you add, instead of needing to think where do I include it, how do I hook it up, etc., it's just create your service, add it to the array, the rest works out of the box. The basic service will then look like this, just a class that implements service and does something. That's the most basic service you can think of. And any other piece of code can request that service and then call methods on it. Then we have, if we have a service with a dependency, we use dependency injection, as I said, so we always inject the dependencies in the constructor. That's important. So never put your add hook, add action, and add filter calls in the constructor. That's not what it is meant for. The constructor is meant to put the service into a usable state, but not immediately use it. So here we inject a salary calculator as an example here, and we store it, and now our get salary sheet method can use that dependency to do some operations. And now for the most complex example, here we have a registrable service. This combines a few concepts. So first of all, this is a service. Then it is registerable, which means it needs a register method. In this case, the register method, it adds a shortcode. So if you remember, register means when we hook into the WordPress lifecycle. Here we add a shortcode. The shortcode is basically a call to the render method down below here. And then we have the service be conditional. This is one of the other interfaces that come by default with the infrastructural code. A service being conditional means it has a static method called isNeeded, and if that method returns false, the service is not instantiated because it is not needed in this particular context. So there you can add any logic you need to check for the current context, and so this will allow you to add optimizations to your code that don't rely on the loading order of anything. The optimization is encapsulated within the object that requires it. And finally, we have a renderable method, which means that this is something that is renderable. It's also one of the default interfaces because it then makes use of the views subsystem. So this looks rather complicated for this basic thing, but what happens here is, I don't know if you noticed, we have a salary sheet here. This is a service dependency, and we have a directory here, which we're using here to create a new view. Both of these are automatically injected by the dependency injector that comes with the plugin Boilerplate. So you don't need to worry about where you get a reference to this. You don't need to instantiate them yourselves. It's just that when the salary sheet shortcode service is being instantiated, the dependency injector will check, well, what do we need? What dependencies do we have? And it will first make these available. Maybe it needs to instantiate them first. Maybe they're already available. You don't need to care. Again, you get rid of the dependency on the loading order. It's just that when something needs to be instantiated, it will be. Otherwise, we're just reusing what we already have. And it's just being instantiated here. So in your regular code, in procedural code, probably the code to render something would be much easier, but this logic here would be in a completely separate place and very easy to break because it directly depends on the loading order. So we got rid of that, and all of a sudden we can easily grow our complexity, and even if we have 1,000 services going on at the same time, if you make a change, we only need to make it in one place and we know we're good to go. We never need to check all the rest of our code to see if it still makes sense or not. There's a website that's not yet live that I'm working on that will have all the documentation and so on. This is already live. This lets you register your email to get updates. And this is also live. There you can directly look into the source code as it is now. It doesn't come with proper documentation yet, but it has lots of comments already in the source code. So you can probably already make sense of it. But the tooling is not yet done to automatically create a new plugin out of this existing boilerplate. That's still a work in progress. Yeah, that was it from me. And I think I'm already past the time. Do we still have time for questions? Yeah? Are there questions?
Do you use some engines to the access to the database auto-render the views?
Excuse me, I didn't.
Do you use some engine, something like Twig or ORM, like Eloquent?
No. So the plugin boilerplate only deals with making these services work properly with dependency injection, so that you can grow your code easily. It doesn't deal with giving you any services or so. So there's no ORM or view template.
To render some views, you have to instance template engine.
The view system right now, it comes with what is called the simple view factory and the simple view and the simple templated view. It's very simplistic implementations, and you can easily replace them with something else because you're only relying on the interfaces, not the actual implementations. So if you want to use Twig, if you want to use Blade or whatever, you can just provide a small adapter implementation that implements the interfaces we need here. That's just one piece of code, and then you're good to go.
Do you have any advice for when there's multiple dependencies injected? For example, when a constructor
When your constructor grows too long, that's usually a code smell. That means that your service is probably doing too many things. So you should probably split it up into multiple services. Only if you use dependencies through Composer. Right now, the way it's set up, it comes with a bundled autoloader that bypasses Composer if the vendor folder is missing. So if you don't use dependencies with Composer, you don't need to pull in the vendor folder. It will still work as is. Yes. So the bundled autoloader also uses PSR4, and it will just work even without the vendor folder. It's just when you pull in dependencies via Composer, well, these dependencies only exist in the vendor folder, so the vendor folder needs to exist in the plugin repository as well. However, there's many more details you need to care about when using Composer for a plugin you want to upload to the plugin repositories. There's dragons there, because you probably will need to think about scoping your dependencies first, because otherwise you'll have conflicts with other plugins that use the same dependencies. Thank you.